Professor Bialis here. In this video, we're going to be talking about section 9.4, which is talking about graphing linear inequalities and systems of linear inequalities. Okay, I like to tack this on in between chapter 3 and chapter 4 in the text. Okay, but even if you are in chapter 9 and you want to have a little bit of review, feel free to go through this material as well. So again, this is section 9.4. And we're going to jump right into some examples on how to graph these things. Now, let's start out with something simple, kind of ready to go. Let's say we have y is less than 1/2 x minus 4. Okay? Now, what we're going to do to start is graph the points of this equation or inequality as if it were an equation. Okay, so imagine this was y equals 1/2 x minus 4. That's in that nice slope-intercept form, so we're going to go right into y-intercept and move with the slope. So I'm going to start by going down 4. Find my green marker here. I'll use blue. Okay, so down 4 to 4. And then we have a slope of 1/2, so that's an up 1, right 2. Up 1, right 2, and we can continue that as many times as will fit on this grid. Remember, you can go the opposite way as well. Instead of up and right, I could go down and left. Okay? Now normally, if this was an equation, we would just connect the dots and be done. However, with inequalities, remember when we were graphing just regular inequalities on a number line? There were two components to that. You put that number down, and then we always put either an open dot or a closed dot. Now, if you remember, if it was like this or like this, that was an open dot. If it was like this or like this, we had the closed dot. Now, in this case, we're not graphing dots, we're graphing lines. So how do we denote these two things in a line? If it would be an open dot or one of these symbols, we are going to use a dashed line. That means that that is a barrier line that we approach but never truly touch. If it was one of these, we would be using a solid line. Okay? So in this case, since it is strictly less than, we are going to be using a dashed line to connect those dots. Okay? Now, the other aspect of this is that shading. Typically, we were shading left and right on that number line. Okay? Now, when we're graphing linear equations, I don't want you to think left and right. I want you to think up or down. Because depending on that slope, left and right could have different connotations. So I always want you to think up or down. Now, there's a kind of drawn out way of doing this and then a quicker way. I'm going to show you the drawn out way first so you have an understanding. But then there is kind of a little trick we can use to help us. Okay, now we will be shading here or here, one or the other. Now think of it this way. If I said I have a quarter in one of my hands, how many hands do I have to open up for you to know where that quarter is? Okay, I don't have to open up both of them. I have to open up one of them. Because if I open it up and the quarter's there, great. If it's not there, it has to be in this other hand. So what I'm going to do is I want to see, is there shading somewhere here or somewhere here? I'm basically going to open up one of the hands. So what I do is use what's called a test point. So I am going to test any point I want, as long as it's not on the line. So the nicest point that we usually try and use is 0, 0. 0, 0 is not on the line. So I'm going to test that. Okay, when I test it, I mean I plug it into the inequality and see if it works. So if I plug this in, I'm going to have a 0 less than 1/2 times 0 minus 4. 0 less than negative 4. Is 0 smaller than negative 4? That is false. So what did I essentially just do? I had my two hands. I tested a point on this side of the line. I opened it, there's no shading. It was false. So where must the shading be? It must be down here. So when I shade this, I'm going to shade this side of the graph. Okay? Now, technically this should be completely colored in, but then I'd be going through a marker every problem. So when we're shading this, we just want to make sure it's clear what side of that line we are shading on. Okay? If I tested 0, 0 and it worked, that means boom, they're shading up here. I would be shading above the line. Now the trick that we could use is when we're in slope-intercept form, only in slope-intercept form, and only when the y is on the left, I read that as a less than. Less than, would I connect less than with above or below? I would think less than goes with below, so I shaded below. Okay? As you're getting used to this, what I would do is use the test point and then verify the test point with that. Use them both. These aren't long drawn out steps. They take you a few seconds each. So do both of them so you can really make sure you're doing everything correctly. Okay? So we plot points like we always do with slope-intercept form, and that's the method of graphing I would typically stick with. Table of values and intercepts are fine, but you can get more points using the slope-intercept form. So that's what I would usually stick with in this case. So we plot the points, and then solid or dotted line, based on the symbol we have, and then we have to shade. Okay, that's pretty much it. Let's look at a few more examples. Let's say we have something like this. Say we have that. Okay, again, what I would suggest you do, get y by itself. Not only does it give you that slope-intercept form that's easy to graph, but also then you can use that less than is down, greater than is up kind of trick. So I'm going to start by doing that. I'm going to move this x over. As always, put that x term first. Then I'm going to divide by -5. And I get y less than or equal to 2/5 x minus 3. Okay? Now, what is wrong with that? Okay, remember, with inequalities, if I divide both sides by a negative, or multiply both sides by a negative, the inequality symbol has to change. Okay? So I should be doing that. Okay? Now, once we get to that situation, we are going to graph. So I'm going to start by going down 3, and then I have a slope of 2/5. So I'm going to go up to right 5. Up to right 5. 2, 4, 5. I can go the other way as well. Instead of up and right, I go down and left. Let's do one more. Down and left. Okay? Now in this case, since that is an or equal to, we have this line underneath it, I'm going to have a solid line going through. So we've got that. Okay? Now the last part is that shading. Now if we look at this, greater than would show up. So we should be shading up here. But let's verify with that test point. Now when you use a test point, I highly suggest don't use a test point here. Because if, let's say, we made a mistake with that flip, then our shading is wrong. That's really the only thing that is affected by that flip. But that's why I would go to the original. I'm going to test not 0, 0, or I'm sorry, 0, 0 because it's not on the line. So I'm going to test 0, 0 in the original. I have 0 less than or equal to 15. That is true. Therefore, this point worked. Therefore, I am shading on this side of the line. And there we go. But that is why I suggest you use this trick as an expectation, but then you still do this. Because if we didn't flip this, then we would be shading on the wrong side. Okay? It is always an excellent idea. If you can do a part of a problem two different ways, and those two ways work out the same, that doesn't guarantee everything's right, but that shows you in a very easy way that you're on the right track. Okay? So, let's look at another one. How about that? Now, what's nice about this is we already have the y by itself, so we don't have to do any algebraic solving there. Okay, let's go into plotting points. The points we want start with the y-intercept of 0, 0. Then we're going to move with that slope of 5. So slope of 5 means 5 over 1. Rise 5, run 1. Rise 2, 4, 5, run 1. 2, 4, 5, and 1. I could also go down and left. 2, 4, 5, and 1. 2, 4, 5, and 1. Okay? Now, is this going to be solid or dotted? This is going to be dotted because there's no or equal to. And then after that, we need to figure out shading above or below. Now, above, if I go on here and I move away, my hand's going up versus it's going down. Okay, so this is above, this is below. Now, can I use 0, 0 as a test point? In this case, no, because I'm going through that origin. I'm not testing the regions now, I'm testing the line. I don't want that. I want to test the regions. So the next best thing would be a 1, 1, 2, 2, 3, 3. I like those points because I don't have to worry about which number goes where. If it's 1, 1, I just plug a 1 everywhere. That's not a very difficult thing, but it's an easy thing to mess up. So that's why it's safer just to use 1, 1, 2, 2, 3, 3, whatever you can. Okay, so in this case, I'm going to test 1, 1. Again, just plug a 1 everywhere. 1 less than 5. That is true. So I tested this point right there. It was true. That means the side that that point's on works. Okay. Also, it was a less than. That tells me to shade down. I verified that. I'm on the right track. We're good to go. Okay. How about something like this? How about that? Now remember, this is a special case. Imagine first that it's x equals negative 3. Okay, if it was x equals negative 3, that tells us we have a vertical line. We go on the x-axis to a negative 3, and then we draw our line vertically. In this case, it's going to be dashed, or dotted, whatever you want to call it. And we're here. Okay, now with the shading, this is the only time I cannot think up or down, because there is no up or down. It is just left and right. Okay, now, as I was saying before, you could use a test point with that 0, 0, but this is pretty simply stated. I didn't touch it, it's just there. X is less than negative 3. Where am I less than negative 3? I'm less than negative 3 on that side. End of story, move on. Okay, same thing would be true if we had a horizontal, but in that case we can think greater is up, less than is down. Okay, so that is graphing inequalities, just a single inequality at a time. Let's now talk about a system of inequalities. All that is going to introduce is the same thing we had here, just 2 at a time. What's going to be different is how we shade, and I'm going to explain how and why we're going to do that when we go through these examples. So let's look at something like this. Okay. Now, what this brings back is the system of equations discussion that was taking place in Chapter 4. Okay, now when we dealt with systems of equations in Chapter 4, we always talked about, okay, we're graphing lines, where are they going to cross? In this case, it's not the lines where the lines are crossing, it's where the shading is crossing that we're going to pay the most attention to. So first thing I would do, whenever you have a system of inequalities, again, all that is two inequalities that we're looking at the same time. I'm going to write these in a graphable form. So I'm going to go off to the side, make sure you copy them down correctly, and then solve them both for y. So I'm going to add an x, and then here I'm going to subtract an x, and then divide by 3. Okay. Now I have two inequalities that are in a graphable form. So what I do, I'm going to graph this guy first. I'm going to start with that plus 4. And then I have a slope of 1, or 1 over 1. So I'm just going to go up 1, right 1. And then I could go down and left as well. Okay, now remember, in this case I'm going to go with a solid line. Always stop and think about it before you just connect those dots. Make sure you're using the correct type of line. Now I'm going to shade. Now again, you could use that test point, or you could trust yourself, and eventually we have to trust ourselves. I'm going to say greater than is up. Okay? Now, when I shade, normally I would shade the entire thing. That's truly what's happening here. But since I have to graph another inequality, I don't want a big mess. So all I'm going to do is kind of slightly shade above that line, just so I know where the shading is. Okay, that's all I want to show at this moment. Now I go to the next one. Whoops. And I'm going to go down 2/3. That's a little bit more than half. Then I go down 1, right 3. Down and right is going to give me that negative slope, so that's what I want. Now remember, I'm looking at lanes here. Down 1 lane over 3 lanes. Notice I'm kind of in the same position on that segment. Down 1, 3, down 1, 3, 1, 3, 1, 3. I could also go up and left. Up and left. Up and left. Up and left. Okay, in this case again it's a solid line. And now I have to figure out the shading. Again, it's a less than shading. So less than means I'm shading below. Okay? Now, what I just created are 4 regions of this graph. Let me extend this a little bit so you can see exactly how this is going to come together. Okay? Now, normally I look for where it intersects, but there's more to these inequalities than just the lines themselves. So I don't have to stress about, oh, that's in between, in the middle of nowhere. What point is that? I don't need to worry about that. I need to worry about where the shading is going to overlap. I have 1, 2, 3, 4 regions. Which region or regions has shading from both? The only region where that happens is this region right here. So what we need to do, there's no ordered pair we take out of this. Our graph is our answer. We graph the two inequalities and then overall shade the region where they both overlap. And that's going to be here. This is our solution. Any point within this region here will solve this system of inequalities. Okay, so really you're just graphing two at a time. The added bonus here is we need to shade the overall region where they overlap. Okay, let's look at a few more examples of this. Let's say we have that. Okay, now again, I want to make these both have a graphable form. So this first one, y is already by itself, but I want to put it on the left so I can use that greater than means up kind of trick. Just make sure you flip everything. The relationship has to be maintained. 2x is smaller, 2x is still smaller. So this is now graphable. I need to make that graphable, so I'm going to subtract 5x. And I have y less than negative 5x plus 5. And now that's graphable. Okay? So let's go with that first one. The first one has a y-intercept of 0. And it has a slope of 2, or 2 over 1. So I'm going to go up 2, right 1, up 2, right 1, and so on. Oops. Could go down and left. Like so. It's going to be a dashed line because it's not or equal to. Continue that throughout. Now the shading. Again, it's a greater than, so I'm going to shade up. If you're uncomfortable with that, use a test point. There's nothing wrong with that. So I'm just going to shade a little bit so I know which side I fall on. After that, I go to the next one. I start with a 5. So 2, 4, 5. And then I have a slope of negative 5. So I go down 5, right 1. Down 5, right 1. It's a very steep slope. Could also go up 5, left 1. And again there, I'm going to have a dotted line because it's not the or equal to. And there we go. Now that's a greater than. So where do we shade with greater than? Not down, we shade up. So we have shading there. And then finally, where do we have shading from all? Or both, I should say. We have 1, 2, 3, 4 regions. The only region with shading with both, from both, is in here. And there we have it. Okay? There's a lot of good bookkeeping that has to be taken care of here, especially when we're doing all this shading and all this graphing. Just be careful not to make a mess, because then you don't know, which is which. Okay, so let's look at a couple more. Okay. Okay, so first off, same as always, get them in a graphable form. This one already is. That's just a nice horizontal line, leave it alone. The other one just requires a little bit of algebra. I'm going to add the 2x to get 5y less than 2x plus 10, and then I divide by 5. So y is less than 2/5 x plus 2. And that is now also in a graphable form. So let's start with this one, okay, because that's pretty easy. I don't want to put this easy thing in, crowd the graph, and then I have to figure out all these points. It doesn't truly matter, but I like to do the more complex one first. So I'm going to go with a plus 2. So that goes up 2. And then I have a slope of 2/5. So up to right 5, up to right 5, and then I can go the other way as well. Down and then left. Okay, that's going to be a dotted line. And then I am going to shade less than, so that would be down. Okay. Next, I just go to that horizontal line, which is on the y-axis at 3, and then I do a horizontal. This is going to be a solid line because of the or equal to. And then I am shading below because it's less than 3. Okay. Now, I still have 4 regions. I have 1, 2, 3, and 4. Okay? Now, the only region that has shading from both is this big region down here. I have this line of red and this line of blue. So all I do is show that this whole thing is what we're looking for. Okay? Again, it should be all colored in, but just make sure that it's clear what region you're aiming for. Okay? So, one other situation I want to talk about, and then that'll be it for section 9.4. Let's say we have something like this. Let's go with that. Okay? Now, we should look at that and right away recognize these are vertical lines. Now, if you remember back in chapter 4, vertical lines are parallel. They're never going to cross. In chapter 4, we would automatically just say, no solution, move on. However, in this case, it's not the lines we're looking at. It's the shading that we're looking at. So if we were to graph this, watch how this plays out. X is greater than 3. So I go to 3, I draw my vertical line, and I shade greater. So I go to the right. If I go to the next one, I go to 1, 2, 3, 4, 5. I draw my vertical line. I'm sorry, this red one should have been dashed. And then I have a solid blue line here for that 5. Okay? Also greater than. Now if you notice, we don't have 4 regions. We have 1, 2, 3 regions. And if you just glance at it, you're like, well, they don't overlap. But they do. This red shading isn't blocked by that blue line. That red shading is going forever this way. So is the blue shading. So where is this overlapping? Right here, because the blue shading is this way and the red shading will eventually catch up and overlap that. Okay, so just because lines are parallel does not mean they are no solution in this case. Now, if you had two lines, let's say this was less than 3. Now that's a different story, because what I would have, let me just do a rough sketch here. If this is your 3 and this is your 5, you want to go bigger than 5, less than 3. In that case, does that shading overlap? No. This would be a no solution. So the bottom line is, when you're dealing with a system of inequalities, just because they're parallel lines does not mean they're no solution. But if it is no solution, they would have had to have been parallel lines to begin with. Okay, so parallel lines just gives you the possibility of a no solution. It doesn't guarantee it. We still have to dig in and see where the shading falls out. Okay. Also, be careful when you're looking at something like this. This shading is on the right forever. That red shading keeps going and going. Okay. So again, really nothing new with this. We're just graphing with systems or with slope-intercept form, but be careful with your shading, and also please pay attention with the solid versus dotted lines. Okay. So as always, work hard. Let me know if you have any questions, and I'll see you next time.